Hi, and welcome to this webinar about Agentic Architecture. It will focus mostly on the Agentic Architecture around the Microsoft technology stack and Copilot Studio, but it's more or less generic and based on our current understanding of this, and this is an area that's changing quite fast, so it is hard to know exactly how this will develop in the future. So um, if you have any comments, please make sure to send them to me or leave a comment below if that's possible, depending on the media. Well, let's start. Who am I? My name is Gustaf Westerlund. I'm a Master of Science in Electrical Engineering. I founded a company called CRM-Konsulterna, or CRMK. I work as a principal consultant and also the CIO of the company. I started my journey with Dynamics in CRM version 1.2, which was sort of the first international version. And I've been happy to be awarded the Microsoft Most Valuable Professional Award for 14 years in a row now, and also got the CRM User Group All-Star Award in 2020. And I'm co-founder and organizer of the Nordic Summit, which is the largest Dynamics and Power Platform conference in Northern Europe. You'll be sure to find me there next year, so make sure to attend if you are close in Northern Europe. Well, let's start from where we are right now. I would say that the bots have been around for quite some while. We have had simple bots that are hard-coded. Typically, I was part of an early version of a bot that simply just looked for specific keywords in the text, and then when it found those words, it then just had some static replies, more or less, to that. It was a bit helpful, but it was very more Q&A oriented. It's hard-coded and just based on that. It's also it's one single bot, so it wasn't very specific. It wasn't very specialized in any way. And also, we've tried internally here at CRMK to use, for instance, Q&A Maker, which was a tool from Microsoft for some time ago, and that was great. It could help. You could put up some documents, and then it would be able to do like a questions and answers perspective of that. However, many of these tools, the initial PVA. Power Virtual Agent, which was its name, you had to sort of configure all the paths, all the logic, or you had got a very simple just Q&A type of response. So I think this is sort of where we're coming from, and so let's go into where are we going. I think also that when I'm going to present these different types of bots and agents, you remember that sometimes it's good to have one of the older types of agents. So I would say that this is not really maybe an evolution. It's partly is an evolution, but also partly isn't, because sometimes a simpler version of a bot might be right for the use case that you're trying to solve. So it depends a little bit on the use case. First of all, we have the classical simple bots that I just spoke about. Typically very chat-oriented or passive, that you send in some data to it, or you chat with it manually. It can answer maybe questions and answers. You ask it something, it responds. Often not very contextual, meaning that it doesn't really understand who you are, and it would often requires quite a lot of work to make it a bit contextual, so that if you say, I have a question about a specific order, and then it would ask what order number, and then you want to input that. That's typically not what these can do, because that requires quite a lot of work. And so typically quite strict flows and topics, and they are quite high maintenance, because you do have to sort of work with all the different paths that you have in the system, or you want to set up for the bot. A good and bad part about these types of bots are that they are deterministic, meaning that you know exactly how they will answer, and they will answer the same time every time. So if you input a specific phrase, you will get the same answer every single time. We then move on to agents, and the main difference between a bot and an agent is that an agent can do some actions. It can act, it can do things, and for this it typically does have a bit of a more advanced architecture. so that it can handle different kinds. It can maybe communicate with an API. These are still quite passive. It's a chat. You send these things to the chat, and you also often have to have quite a strict flow of logic or topics, which makes it deterministic, and then you know what it's going to do. Which can be very valuable in some cases where you don't want it to be very. It shouldn't be creative. It needs to be very strict. For instance, in areas of high compliance demands, for instance, or where there's lots of money involved, you might want the bot to be very stringent and strict, so it doesn't sort of, of course you can have a refund, and it's like, which has happened, for instance, in the very, very famous case from Air Canada, where a person chatted with their bot based on ChatGPT, and the bot said, yes, of course you can have a refund on your trip, which the user in this case, or the customer, took a screenshot of, and then when he wasn't able to get the refund, he sued Air Canada and won. So that's in those cases it can be very good to have a very deterministic bot, because then you know what it will answer in specific cases. So next type of agent. Next type is a generative AI agents. These are still quite passive agents, because they expect some kind of input. And when you go to, for instance, to ChatGPT, it's a generative AI agent. It can act based on what you input to it, but it's waiting passively for an input. It doesn't act that much. There are some functionality in ChatGPT to make it more autonomous, which I'm coming to, but generally it's more passive. It can do actions, it can do questions and answers, but it does actually try to understand what are you trying to achieve, and that means that it's constructing the logic to sort of solve your problem. And it can use all the available tools that it has underneath. So, for instance, in ChatGPT, you can see that you ask it about things, and then it might go search the web and might sort of reason with itself for some time to start trying to figure out what seems to be best. And if you upload a file, it could, for instance, look into the file and see, but maybe this, maybe that. It will sort of try to figure things out. This means that you don't have to sort of describe all the scenarios for it, everything it needs, every way it needs to think, because it can figure it out itself. And an important aspect of this is that you then get a bot with a lot lower, or an agent with a lot lower maintenance. You don't have to maintain it that much, because it can sort of, you don't have to define all the paths. You just give it more understanding of what it's working with, and then it will do more on itself. A negative part of this is, or negative and positive part, is that it's non-deterministic, meaning that you can input one time, and then you input the exact same thing a little time later, and you will get a different input. And this is partly due to the fact that there are a sort of you can input a temperature into different AI models, saying how much of the variation do you want to have it. So in some cases, you can actually just take the temperature down to 0, which means that it will become fully deterministic, but you don't really know what it will answer. It will answer the same thing every time, but you don't really know what it would answer beforehand. You can't go in and check the flow in the code, right? So it's still would in those cases be the same answer, but not the same answer every time. Or you can't foresee it anyway, because you can't sort of backtrace through the logic. Yes, and then the final type of agents are the autonomous generative AI agents. And of course, we have autonomous normal agents, not only generative AI agents, which are, of course, in that case, a mix of this one and the second version. The main difference here is that these types of agents are event triggered. So that something happens, an email is received, somebody sends a chat in Microsoft Teams or in Slack, and it will act based on this event. And then it can do all the things that the normal generative AI agents can do. It can sort of take that input that's coming in the email, for instance, and then do things with that. Maybe look things up. So you can have an autonomous Gen AI agent automatically answer emails, for instance. That you get, and You have to be careful because you don't really know what it will answer, and maybe if it answers right one time, it maybe not answer it correctly the next time, because these are generative AI. So from that perspective, it's quite similar to this third one I just showed. Yes. So how do we use data with these different types of AI agents? The first version, and I think that's quite common, is to use prompting. We concatenate prompts, meaning that we sort of put together a lot of text. We can have a big prompt, and then we have variables that we put into this prompt in different places. And those variables will then sort of make a full prompt, and then that will be used for the AI. And this is quite easy to do this. It's also easy to test and to develop, because you can sort of fake the program that's putting all this text together and just do it yourself. So for instance, if you wanted to test to build a prompt that summarizes orders or cases or something like that, you can sort of fake, like, please summarize the following order, and then give it some instructions. And then you just, for instance, ChatGPT or Azure AI Foundry, you go in and just add that text yourself manually, and then you can try it and see how it works. I usually do this with Notepad, and I have copy-paste text. I have ready text in Notepad, and I copy-paste them into this, and then that way I can develop the prompt so I can make it a little bit better. You can also add files to the prompts. This was a feature that came out about a year ago or something, where you can actually upload a file. This is a very powerful tool, powerful thing to do, because you can upload almost anything, and it can understand a lot of different types of files. It depends a little bit on the model and where you're using it, but the file itself becomes part of the prompt in those cases. So very useful way of doing this, and it's also I typically start here when I do things with prompt engineering. Another good thing about this is that you can use a generic model, so you don't have to have a specially trained model. You can just use any of the models that you have. You can try to maybe start with an advanced one and then go back to a cheaper one, because the price differences of these models can be very, very large. So that's something that's good to understand. There are also lots of tools to choose from, or different types of models. You can use Claude, or you can use ChatGPT, or models in Azure OpenAI, DeepSeek, for instance, and so on. And it's also easy to change or upgrade the model. So you might start with a model, and then OpenAI releases a new model, and you want to use that. It's very easy to just switch model. You just more or less replace the call and call another API, but with the same type of input. So it's easy to work with that from that perspective. One of the cons for this is that it has you will have a limited token length in this, depending on the type of model you choose. It will you will not have the same. There's a limit to the length. So the more advanced models like GPT-5, for instance, has very long token limit, so you can upload quite a lot to it. But you have to think about the token or credit costs in this case, because the cost difference between these different models is very, very large. So sometimes it can be several hundred times the difference between different models. So it's very important to choose a model that's right for your use case, and don't take a model that's too advanced. There are, for instance, mini models in the Azure AI Foundry that's called, for instance, GPT-5 Mini. Use that if you can, if it's good enough for your use case, which many times it can be. For instance, if you're doing trying to figure out which tag, if you have a list of tags and you want to say like, please categorize this text based on these tags, that's something that you don't have to have an advanced model for. So then that way, please do try to use that. That will reduce your costs quite significantly, and also, of course, you're not using more resources than you need, and that's also reasonable, because AI is using quite a lot of resources. Yes. The next way of adding data to an agent is adding files to an agent. This is similar to the next method that I'm going to describe, which is called RAG. You can use this, for instance, in Copilot Studio or other scenarios where you have where there's a bit of an architecture on top of the models. They will typically use RAG underneath, but it becomes a bit different because in this case it's quite easy for non-technical users just to upload a file in SharePoint and then just link to that. There are limits to the size of the files that you can upload, and it's also hard to maybe control the details of exactly how you do this because, I mean, it's a bit of a black box where you upload the file into Copilot Studio, for instance, and it will use the file. Maybe there are scenarios where you want to use specific parts of the file and so on. In those cases, it might be better to just use RAG instead if you have the technical capabilities. Sorry, a bit of a cold. I had to get some drinks. Yes. So let's move on to the next one, which is called RAG and Retrieval Augmented Generation. In this case, what you do is that you use some kind of indexing engine to index something, and it could be files, for instance, or databases. And then you can, based on the index, you can add it to the AI to use that data. And this is very useful if you have large sets, like you have hundreds of thousands of products that you want to be able to sort of find out what product is the customer emailing us about. Then you maybe want to look at your specific list of products, and you don't want it to start searching the web for products. And in those cases, the RAG is a good way to handle this, because then you can control that very specifically. And in those cases, also maybe that you want the product data to be in your database, in your ERP system or CRM system or PIM or something like that, and then you want it to based on that and not just on a file somewhere, because that could change, and it's not the same master file. You might need to reindex things and handle a lot of that, but also the cost is lower of doing things directly in RAG than using Copilot. So it can definitely be an option to look at RAG. It is quite a bit more technical, so you do need to have people that are a bit more technically skilled. What you can do then is that you can also train a custom model. Training a custom model is time consuming. It means that you need to have training data and then train the model on, like, this is what the type of patterns that we're trying to look for here. And it is time consuming. It does require very good data, because if you have bad data, you will teach it bad patterns, which is, of course, can be problematic. And it's also hard to know if you have good enough data, but you can also test your models and so on. But it's also a skill thing. You need to have the right skills to be able to train a model. And the good thing about this is that if you want to have models that are offline, that need to be smaller, because these GPT-5, for instance, it's huge. It requires a data center to run. But if you want a small model, maybe to be running on a local computer or a phone or something like that, then using a smaller model is definitely an option for that. So that could be an option in those cases. The negative part about this is also that if you start doing this on one model and then there is a new model coming out, when you want to change that model, it's hard to change because you've trained the model. So then in that case, you need to redo the training once again on the new model. And there's also costs incurring when you train the models. So you need to, and those costs can be quite non-trivial anyway. They're a bit high. So you need to think about that a bit to make sure that you do this only if you actually need this. There are definitely scenarios where it's good to have a custom model, but not. Or I would start with the other alternatives first, which are typically would be easier to do. And then there's quite a new tool or tools which is called MCP servers or MCP. And MCP is sort of like, you think about your computer and you have a USB-C that you can connect things to your computer, like a camera or a different microphone or whatever you want. This is same sort of thing, but with AI. So you'll be able to connect things to your AI. Typically, it would be the other types of systems, like a CRM system or an ERP system or Microsoft Teams or Outlook or whatever, like any other type of system. It's not typically used for AI to AI communication, but more like AI to communicate with the rest of the world. That's typically what MCP stands for. And it's sort of like an API, if you know an API, which is a way to program towards other systems. This is sort of like an API, but it is used for AI. So you can have no normal API will say these are the things I can do. These are the endpoints. These are the methods that I can use and the data I require. But the model context protocol sort of adds on top of this, and it tells the consuming party, in this case an AI, what can you do? Like, I'm a customer agent. I'm a customer relationships and management system. I have information about customers. I have information about customer service cases, for instance, maybe marketing things and so on. So it also tells the consuming party what it can do, which means that if when an AI starts communicating with it, it says, "Oh, I'm looking for somebody who can help me with the customer information," and it's like, it contacts the Dataverse MCP, and then Dataverse MCP says, "Yes, I have customer information here," and then it knows that it can talk to that. So it's a good way for AI to be able to communicate to other things. You do need to have some kind of MCP client to use this. This can be Copilot Studio, for instance, that sort of actually communicates with an MCP server. The MCP server is sort of the API, and the MCP client is whatever communicates with the server. You can do both. There are both what's called tools and resources. Tools is something where you can do something, like for instance, I want to create a case, or I want to create a customer, or something like that. And then you have resources, which is more like, these are articles that I have access to. You can read this, and also you can have example prompts and stuff like that. So it can say, this would be an example prompt that you can post to me, and that's also good for the AI coming in, that it can see these prompts and get like, oh, okay, this is typically what I could ask for. And this works best with generative AI, because then it's using this method to sort of try to figure out how to get the data that you're asking for by sort of querying the MCP servers. Yes, and it's also possible for AI like when you build an agent, it's also possible to use their APIs directly, but in those cases you do have to describe what does this endpoint do. So connecting to a specific endpoint, it's called accounts in Dataverse. Okay, you then have to sort of tell it, okay, in accounts in Dataverse, this retrieve endpoint, method will give you a list of, or will give you a specific record, and that's a customer. And then it can use it, but it requires more work. And since this information about what you have in your system is sort of the same more or less all the time, then it's better to use MCP, because it's easier. It's easier to connect to that when you're building agents. Okay, next topic: agent specialization. And just like humans, we do think that it's better to have specialized agents that do specific things. And so why not have one agent to rule them all, or like a jack of all trades agent, an agent of all trades. Well, the problem is that the agents typically, if you start looking at it in detail, you will notice that different types of agents they're responsible for different types of things. And sometimes if you try to sort of put everything together, it will just blur things. So it's better to separate agents into different parts or into different roles and jobs, more or less, to different specializations. So a sales agent, for instance, that helps you with for instance, answering RFPs or something like that, is very different from an agent that helps somebody in customer service, because it will respond differently. It does need sort of gives different information and so on. An agent that's used directly for being customer facing is of course also very different from an agent that's used for internally, because they need to maybe have harder separation between different customers and so on. So there's no data leakage from one customer to the other when you're using it externally, but internally that is not maybe as big of a problem. So you can sort of handle that a bit more. And different tasks require access to different things. For instance, if you have an agent that's responsible for answering product related, being a product specialist agent, you don't want that agent maybe to go out and search the internet for products that sort of fit whatever you're talking about. It should only answer based on the products that you have internally in your organization. And that, of course, is independent of if it's internal or used internally or externally. Internally, it might be that you want to see more information about the products. Externally, maybe just a limited subset of that information. But the product specialist agent might just be able to answer product information in general, and then you slice it later on. But generally, you would see that in that case, you don't want access to the internet. But when you're talking about other things, it might very well be that it's good to use the internet, and they use web resources that are available online. It could be if you don't know what kind of question you would get generally, but it might be that, can I use this product for this in this type of scenario, for instance? Then figuring out what that scenario might be would be maybe good to look up on the internet, but then the product specification part you need to have connect to your direct data, right? So you can be very specific about that and what it can do. Okay. So how do we organize our agents? I would just on a high level try to say that if you would have a company and you had infinite amount of money and ability to specialize, and you would have one person doing this and one person doing that, and we have one person in the reception greeting customers that are coming in. We have one person in our company that's manager and managing all the other people, and then we have one person that's responsible for taking all the reading potential RFP from top to bottom and understanding the entire thing and saying, this is what it's about in general, and trying to grasp that, and then also maybe answering questions about the sort of RFP on a very high level. And then maybe we have a sustainability specialist in extracting sustainability requests from an RFP. And then maybe there's a sister agent to that's able to answer all these sustainability questions. And then there's a sister agent to that's sort of being able to validate the answers of these agent that sort of figured out all this, what was the correct answers to the sustainability questions that we got. And when you put all these together, you can then link them all together. You can get a better answer and a more granular ability to sort of map it all together. And an example architecture of this would be, for instance, if we have different resources. So we have some GDPR guidelines, there's Dataverse, there's a product catalog, maybe there's an ERP system and a CV database, and then there's something behind me that we can't see right now. Well, first of all, we add a couple of different MCP servers. In some cases, these MCP servers are supplied, for instance, in the Dynamics 365 and Dataverse scenario. There are several different MCP servers. There's one for Dataverse, there's one for Dynamics 365 Sales and one for customer service, and so on. So there's separate servers here. The reason why there's separate servers is that the Dataverse MCP is quite generic. It can answer. It sort of knows that it has tables and it has fields and so on, but it doesn't actually know that much about what is a lead, for instance, which the sales MCP does know. Even though it's working with the same data, it has a more higher semantic understanding of what the data it's working with is. And then we can add, maybe in the product catalog, we built this product catalog ourselves, so we just have to build our own MCP server on top of the APIs. And for the ERP system, maybe that was some other system, not a Microsoft system, and they might have their own MCP that they have built. And then for the CV database or PIM database or whatever we would be, then in that case we just say that, okay, yeah, we just go with API in this case, because it's not that big of a question. It's not so wide that we want to use this for. So maybe just go with the API and then describe that from the agent instead, and so on. So then if we have, for instance, a customer agent, we would start like linking the relevant parts into that. In this case, it would be the GDPR guidelines and also the Dataverse MCP to sort of, this is where you can get the customer information. And then we would have an order agent, and the order agent, in its turn, maybe we typically would sell products, and then we have a product agent that sort of communicates to the order agent using a protocol called agent to agent. So it's not using MCP, it's using something called agent to agent protocol, defined by Google. And this product agent then, that sort of the order agent asks the product agent, can you give me some products that match this request, for instance? And the product agent would then work with, for instance, the product catalog and maybe the ERP system. ERP system might, in this case, for instance, have the customer-specific pricing and so on, so that it can sort of return, these are the 5 products I recommend for this scenario. And then the order agent will maybe talk to a services agent. The services agent will then go to the CV database and also the ERP system to be able to put together, these are the recommended people or services that I recommend to offer in together with the rest of what we are putting together here. And then there might be, for instance, delivery database or logistics database where we can control all different types of logistics. And then that's the order agent communicates directly to that with via an MCP. And then we might have the customer agent that's also feeding into the order agent, so we know more about the customer. And then we could just have some kind of agent flow at the top, where it goes through different steps. First, we start by looking at this, and then after that we always go through the order agent. We generate the order that we want to sort of have as a draft. Step 3 is that we validate the order and see that it actually seems to be correct. And step 4 is that we send that order to an order confirm, or like an actual quote generating functionality or order confirmation document generator or something like that. That will generate the documents and then send that over to the customer. And in some cases, some of these steps might not at all be any AI based. They might just be classical automations, like having a Word template where you put in data and then based on an order, and then it will generate that data. In this case, if the top steps here are, of course, quite deterministic in that sense, it's always going to go through these steps. And sometimes you don't want that. Sometimes you want it to be more Gen AI and sort of try to figure out what you want instead. And in that case, the top agent would be some kind of conductor. And this is, of course, one scenario what we have here, where we have this conductor could, for instance, be the customer service agent that we have, and it could, and it uses it, or in this case, is a sales agent that puts together orders and answers RFPs, for instance, a part of that anyway. And but then, of course, if you have another agent that's maybe customer facing, maybe it will also use the customer agent to generate the part of that in its response. Or maybe it will also use a services agent, but it never uses a products agent, for instance, because it might not be allowed to place orders, but you can ask questions about products and services that are available. So it just uses the products and services agents, but not the order agent, to be able to handle that. So there could be good opportunity to sort of create a sort of resource, a layer of resource agents here, where we have agents that sort of handle different things within the enterprise architecture, and it sort of that facilitate other types of things to top agents that sort of are the agents that we communicate directly with, or that our autonomous agents use. So it's that's sort of a bit of an architecture around that. So when we're thinking about things like this, it's good to think that we can have different types of agents. We can have conductors or managers that are sort of trying to figure out, like, so I'm getting an email here. What's this email about? The email, oh, it's about, this is a customer service request, so I should send it to the customer service agent. Or the email I got here, it's actually somebody who wants to have a quote. Maybe then I should send it to the quote generation agent. And so on. So it sort of just conducts, and this maybe in some cases maybe splits the questions into several parts. If you maybe have an email coming in and it has part of the email is about a customer service case that somebody has, and then it says in the end, oh, by the way, I also want 5 more of this add-on stuff, or the printer cartridges or whatever, and then you wanted to be able to handle both those things in the same email and then maybe it needs to sort of conduct and use several agents to answer those questions. Extractors are specialized in extracting data from like large amounts of data. So for instance, if you get an email and you want to be able to extract what products it's about, then you want extractors that are that extract any kind of information about products, maybe, or just like sustainability things, or quality types of issues, or specific compliance issues, for instance. And these agents are good at extracting those types of data from whatever text you have. And then we have solvers, and the solvers will take what's been extracted and then try to solve that. So somebody says, oh, I'm looking for this information about these products. So the extractor will just take out those specific parts. It won't look it up into any product catalog. It will just like extract those and then say, oh, there's actually 5 different products requests in this data. And then the solver will take that. It will then try to solve it, each of these 5, and match it to the products that we have in our product catalog, or the services, for instance, in that case. What then needs to be done is that we need to validate that, because of course we have the problem with AI that it can be it can hallucinate a little bit. So sometimes the responses it gives are not as good as we wanted. We have seen scenarios where we put together a quote, and the quote then has like 4 of the 5 products, for instance, they seem to be very they sort of are in the same type of scope and for the same type of product group, for instance, but the 5th product is totally off, and it's for some reason the AI couldn't find, and the best version of what they found was something totally different, and it's like it doesn't make sense. So then in that case, the validators are there to make sure that whatever it's extract or the solvers try to figure out is actually seems correct. And then if it's not correct, it will sort of like call the solver again and to see if it's possible to get a better answer. Will tell the solver that, look, this was not correct based on this fact, and so on, and it will try to get the solver to sort of work harder and make it better. And then once you have a lot of responses, for instance, then you might have a collator that collates all these responses into a single document, a single quote, for instance. And then after that, you might want it to be communicate. You want to change the tonality, for instance, and stuff in whatever you generated, so that it's becomes very a bit more specific for different groups. Are you communicating to like German corporate heads or C-level people, or are you communicating to Swedish technical people in the IT department? Sometimes you have the one group and sometimes you have the other, and the tonality maybe might need to be a bit different. Maybe you're communicating in Swedish in one time and German in the other, and hence you need to have different ways of communicating. And these are some types of agents, and I think we can probably figure out 5 more if we just sit around and talk a little bit. But just so that you sort of start thinking about what types of agents typically do, and then think about how you sort of divide and split up whatever you're trying to do. And this is a new type of enterprise architecture that we're looking at. That's different from classical enterprise architecture, where we have our ERP systems, our CRM systems, our integration buses, and hybrid clouds, and whatever we have, and the communication between them. In this case, we're trying to split up the business into different domains, more or less, and we have agents responsible to groups of agents that work in these domains, and there are experts in the domains, which is, as I mentioned previously, quite similar to how we handle different similar to how we handle organizations, and how we set up people. Like, okay, but these people over here, they're experts in the customer insights data. These guys are experts in customer insight journeys, and these guys are experts in dynamic sales, for instance, and so on. So we want to have different people there that are experts in different things, and in the same way, agents that are specific in working with specific other areas, so that they can be good with doing that. Yes, so this is the end of that presentation, and I hope you've enjoyed it and that you've learned something. And if you have any comments and think that this is good, then please share it with your friends, or share the link anyway, and like it. And if you think that I'm wrong, that's great. Please leave me a note and I can learn some more. Or if you just want to add some comments to the ongoing discussion about where we're going with AI, that's also awesome. So please do that. Thank you very much.